Everyone, we will solve this today's LeetCode problem. This is LeetCode medium, minimum number of operations to make array XOR equals to k. Right. So in this, we have given a zero indexed integer array nums and a positive integer k, and we have can apply the following operations on the array any number of times. We can choose any element of the array and flip a bit in a binary representation. That means it we can change is 0 to 1 or 1 to 0, right? And we need to return the minimum number of operations required to make the bitwise XOR of all the elements of the final array, which is equal to k, and the k is given, right? So here it is given 2134 and k is equals to 1. So after taking XOR of all the elements of this nums, it should come it should be equals to this k value. If it is not, then we need to change some bits of any element so that after taking XOR of all the nums value, it should becomes k, right, which is k. So the first thing is here, right? We need to flip the binary representation, right? So we need to think in terms of bits, right? As simple as that. Whenever you see that uh, you need to take a XOR or something. So if something is similar to the bits value, so you need to think on bits, right? And I need to take a XOR of something. So for taking XOR, we need to remember some XOR properties, right? What are the some XOR properties? If the bits are same, it becomes 0, and if bits are not same, then it becomes 1, right? This is the simple XOR property, that if the two elements are same, then it becomes 0 and it will cancel out the same, and if it is different, then it will becomes 1, right? So what are the two properties? That even number of times, if even number of times occurs, if bit is set even number of times, then after taking XOR, it becomes 0. And if it is odd, if it is odd if it is odd, then it becomes 1, right? It is as simple as that. This is the XOR properties which you need to keep in mind while solving any XOR questions, right? This is the two basics of XOR properties, right? Now we will think how we can change this XOR values to equals to which is equals to k, right? So let's see the first example, 2 1 2 1 3 4, right? Let's think in XOR, right? So what is the binary representation of 2? It is 1 0, right? It is 1 0. Again for 1 it is 1, for 3 it is 1 1, for 4 it is 1 0 0, right? So if you see, if I check if I check by every index, the first index started from right to left. So if I see from right to left, then it is 0 1 1 0. So this 1 occurs two times, then final XOR will becomes what? The final XOR will become 0, right? For the second index, start we are seeing from right to left, right? We are seeing from right to left. So for second, it is again even number of times, then it will again 0 occurs. If it for third, it is an odd number of times, so it will become 1 after taking XOR of all this 4. It will become 1, right? Why? This 1 and 1 will neglect it, this 1 and 1 neglect it, and this 1 will not neglect any of this, so this will become 1 0 0. It is a 4, right? And we have given a k as is equals to 1. So so what is the binary representation of k is equals to 1? It is 0 0 0 1, right? This is 0 0 1. So if you see in this and this, after taking XOR, here should be 1 and here should be 0, right? So you think of bits. So what, you don't think that if I store this all the bits of every index, like from 0 to 32, if I store all these bits at every index, like at 0 part from right to left, I'm saying from right to left, again I'm saying from right to left. If I store from 0th part, so it is 0 is 2, at second it is 2, at third it is 1. So if I have 1 on any index, if I have a set bit at any index, it means there should be even odd number of times one occurs should be at that current index at all the four, right? what i'm saying what I'm saying is, if I have a set bit, that means 1 at and at ith index, it does mean, what does it mean? It means total number of set bits set bits in all the elements of numbers, all the elements of array, set bits 1, total number of set bits 1 in all the elements of array at ith index in their binary representation should be odd, right? The total number of set bits should be odd. This should be odd, right? This should be odd in all the elements of array at ith index in their binary representation. Then only after taking XOR of all this, there will be shared bit 1 at ith index, right? Agree, right? If I have even number of set bits, then it will get neglected and it becomes 0. So if we have set bit 1 at ith index of k, that it means that total number of set bits should be odd in all the elements, right? And if it is not a set bit, it means it is 0. If it is not a set bit, not a set bit, that means 0. That means 0 at ith index of k, then it means the total number of subsets should be even, right? The total number of subset set bits should be even, right? So now this should be the intuition behind that. That what I'm using, I'm just using this even set bits, it becomes 0, odd set bit it becomes 1, right? So just think in bits, you will definitely know how this is coming, right? So now just what I need to do, I need to calculate the number of set bit 1 at every index of this elements given, like 2 1 3 4. This is 2 1 3 4. So I need to just calculate for every index the number of byte bits. So for 0 it is 2, right? For 1 it is 2, for third it is 1, right? And for fifth it is 0 0 0, right? So this is given like this, right? So this is given like this. So for every index, what I will do, I will store all the index. So for this, it is 0, it is again 0, it is again 0, it is 1, it is 2, and it is 2. The total number of set bits is 2 to 1, right? And k is equals to 0 0 1. So at one index it is 1. So we have even number of index. So but I want odd number of index, odd number of bits, right? We want a odd number of bits. So this need to be changed. Either I will change this any 1 to 0 or any 0 to 1. So that will take one operations. So the answer should be 1 plus. So either I decrement this or increment this. Now what does it mean? Either I will change 0 to 1, or I will change 1 to 0. And in both of the cases, the number of operations should be 1, right? Again, this is 0 at second position. This is 2, which will be neglected. So we will not use any other operation. We don't need to change anything. At this position, this is 1. And this position, this is 0, right? So at this position, this is 1 and this position is 0. It means I need to either change any 0 to 1 to make it even, or any 1 to 0 to make it to decrement it. So that will take another operation 0. This should be 1, right? And for this 0 there will be 0, and again for this 0 there is again 0. So this is how the total answer is 2. So what I will do, right? So there comes an approaches final approach. So the first thing, I need to make all the nums, and I need to change all the all the elements of array to binary representation, and calculate the set bits, that means 1, at at 0 to 32, because if we see the constraints, it is given to inst for 5. It means it will contain to 0 to 30, and it will can include in 0 to 32 bits, right? So at every set bits, so I will check at 0 to 32, I will store the ith bit and calculate the number of set bits at every index from 0 to 32 for each element, right? I will store that, and after that I will also convert the the k element, which is the k value, to binary representation, and now I will match and now I will see that number of set bits at the ith index, and I will check the number of set bits at ith index is even or odd. So if at ith index k is equals to 1, ith index, the bit is set for k. It means, what does it mean bit set is set? Bit is if the index bit, the bit is set, that is 1, then the number of set bits should be even. No, so it should be odd, but if it is even, I need one operation, right? And vice versa for opposite. So what does it mean? That if it is not set and the number of set bits is even, if it is not set and number set is odd, then I need one operation, right? So this is how we will do this question, right? Let's implement it. First thing, what I will do, let's take its length, and I will change its all the elements to its binary representation. So how will I do that? For changing its binary representation, I will divide the number by 2 and 2 and 2, right? I think you must know how to change the number in binary representation, right? So what I will do, I will change all this to binary representation, and again I need to store the number of set bits. For that I need to make a count from 32 for all the index set bit. So now if this value 2 is If this value is this is odd, then I will simply count at jth, right? And I also need to increment this jth part. So this count j should be plus plus. Whenever I get one, I will increment at the int index. I also need to increment this jth value, right? So what does this jth and count jth is doing? So suppose is there is 0 0 1 0 0 0 1 0, right? So when this value is divided by 2, it is started from last part. So jth will also started from zeroth part. So whenever one comes, it stored the number in my at that current index, because when you divide value by 2, it started from right to left, right? It started from right to left. So I will just store this in my array, so that I need to find the count, and just I will start from, and whenever, and this is the whole part. I stored all the set bits. Now I will change this k to binary representation. For that, I will start again uh, J0. Sorry, this should be, yeah, this should be J0. And now for this k, I need to also do change this to binary representation, with the same approach, with this same. So if this k modulus 2 is 1, so if it is 1, it means my total number of set bits at count should be odd, right? So if count j modulus 2 is odd, it means we don't need to increase any operation, because it will automatically give me 1 after taking XOR. But if it is even, then I need to increment my answer, right? So if it is odd, then I don't need to change anything, but if it is even, then I need to increment my answer. If it is odd, so if it is k modulus 2 is 0, it means this should be even. But if it is odd, then I need to change it to answer plus plus. I need one operations for that, right? I need one operations to make it even, right? And at last I will return answer. No, but it can be possible in just this case that k is equals to 1. So it will occur still only this k should be, this k will only occur till it becomes 0. So after that, this j should also be incremented, right? So after that, but there can be also possible that this k has only uh, two occurrences in this while loop. This k occurrences is till 2, so j is till 2. But in all the elements of nums, this can be possible that it is greater than 0 to 16 17 or something. And it also possible that some bits are setted at 14 13 10 or something. That should be also that should be also neglect should be also be decrement or change its value, right? So for that, I need to start from jth value and iterate from this. And if my bit is set already, then I need to decrement it, right? So if it is uh, because at that point the kth bit will be 0, because after that it will be only 0, right? This is 0 0 0. So this should be neglected. So if it is not even, then it should be decremented to make it even, right? So, and this should be return answer, right? Let's run this. Okay, I have not defined answer here. Let's define it. Hmm. uh, I have not defined j. Integer overflow. Oh, okay. I have not. dividing, I'm not decreasing this value too, right? This should be decreasing, right? And here it is also decreasing. There should be this should be divided by 2 to make it decrease again, right? 32. uh oh, sorry, this should be I, not J. Hmm, something is wrong. What is wrong here? I'm storing I, and if the value modulus 2 is even, sorry, odd, then I will increment my count J, because that will be only the number of bits stored. Otherwise I will. Oh, okay. This should be started from 0 only, right? Because for every each and every element there is a separate binary presentation, so it should start from j is equals to 0, not j plus plus, right? Okay, let's run. Yeah, let's submit it. We have successfully passed this case. So what I have done, I have just, it is just an implementation purpose. The main approach is something similar, that I will need to store all the bits at every index of from 0 to 32 for every number, and need to check for the number of set bits, for how many number of set bits are there, either it is even or odd, and accordingly changes to with respect to k is equals to 1, right? So I think you must be confused for this. So this is after the kth element representation is over. So this while k is equals to this to uh, will run occur till k is not equals to 0, right? If k becomes 0, then after that it will not return, but it is possible that the total number of bits which occurs in this k is less than the number of bits occurring in nums, is greater than, right? So so for that I need to start from j to till 32 to see that whether any set bit, the number of set bits is occurring for that or not. Otherwise, so I need to decrement that, right? So yeah, this should be an answer. Okay, so what will the time complexity and the space complexity? The time complexity is O of n, right? And is the number of elements of an array, because I need to iterate in whole array, right? And also I need to making bits to 32, right? At most 32. So it will be 32 into n at most, which overall is O of n, right? So uh, and what is the space complexity? So I'm using O of 32 spaces for storing bits, right? That will be O of 32. So this will be O of 30, O of n, and this will be O of 32. So can we change this O of 32 to O of 1, right? Let's see how can I change this. So let's see what we are doing. We are storing the count of the set bits at firstly, and then checking that whether it is odd or even, right? So instead of pre-computation of the number of set bits in my array, instead of doing that, can I simply take a Xor of all the elements once, and start iterating and start it checking the bits by bits for the k and the final Xor? What does that mean? That if 2, 1, 3, and 4, what does it find? Its final Xor will be. It should be 4, right? Which has binary representation as this 1000, right? Its Xor value is 4, right? So its binary representation is 1000, and the k which is given is 1. Its binary representation is 0 0 0 1, right? So in this case, If I started from last part, this is 0 and this is 1, which is not similar. So you need to change, and you need to change at least one operation, take one operations to change this 0 to 1, right? So the answer will be 1 in this case. For this is parity is same, so it will not be changed. For this parity is same, it will not be changed. For this, its parity is different, so it need one operations to change, so total two operations to change. So see, we got the answer, but how it is coming, it is same as checking the bits previously or after taking XOR, right? Previously, what I was doing, I was storing all the bits after take in of for every elements. But now, what I was doing, now I have taken the XOR value of all the elements. So after taking XOR, it there will be a final value, which which can be represented in a binary form. After representing in binary form, I will check bit by bit with k that at which index it is different, right? And if it is different, then I will increment the answer. That will give me a proper number of operations, right? Right. So instead of using this of 32, we can simply use a variable to for storing a XOR value, and I can iterate in bit by bit. How? Just doing this divided by 2, by dividing each and value by 2 again and again, and checking bit by bit. So what will it change? So instead of using this count, I will take a XOR which should be started from 0, and I will just take this XOR value with every element of elements, right? And now what I will do, I will start iterating into this. I will remove this. This XOR has the final value. Now I will iterate in this XOR. So till k or till XOR, right? If both of them is neglect and both of them become 0, then it should be stopped. And now what will I check? I will check whether this k modulus 2 and XOR modulus 2, if it is not equal, it means both have not the same parity. uh, Parity means here is 0 or 1. So same parity means this modulus 2 will should be 0, and this should also be 0. If it is not, then I need to increment my answer, because both of the parity is not same. And if it is not, then I will not don't increment my answer, and I will also decrement this both of the index for. So what I'm doing, I am just iterating in bit by bit for every index, right? Right. That was I'm doing, right? So till when k and XOR is become 0, it will give me an answer. So let's see if this works or not. uh, Expected unqualified id. Okay, I think this XOR is a fixed means already declared word in C++. Let's take as a value. Value, value. Let's try this. Answer. Okay, I need to also define an answer. After understanding the showcase. Yeah, we have passed the case. Let's submit it. Yeah. So what we have done, we have just make this O of 32 to O of 1 in this case. We have just make it to O of 1, right? Uh, right. Okay, let's see one more observation, right? There should be, this is an easy problem, right? So this is an easy observation after storing all the set bits at the count to this. Now let's see another approach, right? So if you see here 4 and 1, this has different set bits, right? So if I, don't you think if I take it a XOR value, 4 XOR 1, after XORing 1, it becomes 1001, 1001. So how many set bits are different? Here it is different 2. So the answer is also 2. But how will I deduce it? So let's see. If after taking XOR, if we have left 1 at any index, what does it mean? It means there will be changes in at most ith index, right? So at 4 and 1, at 4 and 1, at 4 and 1, if at any index the number of set bits is different, it means that there will be an extra one will occur after taking XOR. So if you think like this, uh, how well, so okay, let's see, there is given 10101, and it is given 001, 1 2 1 0 1, right? So if you see here, after, if I take XOR of this, it means 1, it will come 1 0 0 0 1 1, right? It has three set bits, right? It has total number of three set bits. And what will the answer for this after taking XOR? It will become, it is difference as the first parity, it difference as second also, it is different at third also. So whenever there is a difference between a parity of at any index, that will give me a one, of course, right? uh, Understood? What I am trying to do, I'm trying to do deducing from this step to this step, right? So if there is any changes in the parity, so after taking XOR, there will be one set bits at that index if there is a difference between the parity of at any index between the both XOR value and k value, right? The XOR value and the k value, right? So it means what I can do is, instead of using this, what can I do? I will simply take a XOR, take a XOR between value and k, the final value and k, and count the total number of set bits occurs in this answer. So you can count also like this while iterating in this value, or there is an STL value which is built-in pop count, right? Which give me the number of set bits. So what does it do? This do this is a this is an STL which gives number of set bits present in value in number, right? Number of set bits and binary representation and representation present in number, right? This will give the built-in pop count. So this answer is the XOR value of value in k, and this will give me a total number of set bits. That should be the answer, right? Let's run this. You can also calculate like this while iterating again, and this answer is redefined. Okay, let's make this as value. Okay, let's change this to value only, and this happens. So yeah, we have passed the test case. Let's submit it. So from the O of 32 to O of 1 to more simplify. So now what this lines become, this is something like this, only three lines code, right? After starting from O of 32 to O of 1 to only this three line of code, right? If you see, this is only a three line of code. What I can do, I also can change this to this, this to this, right? This is only a three line of code, nothing else. This is something like three line of code. So from there to there, I just change this to three line of code. That's the simple problem. This is how we deduce the problem from large to smaller one, right? uh, don't need to submit it again and again. I think we will not get any compilation error. Hope so. Yeah, we don't get any compilation error. So from there to here, it's a long process. It's a not comes instantly. It comes with an experience, right? So if you see anyone posting it like three lines of code, two lines of code, one line of code, don't be get depressed, because they have already built, they have already gone through this process, and they post it like this only after they get this final, right? So this is how you get to one line or two line of code, right? So I think you must have understood this. So the time complexity, the final complexity is O of n, and the space complexity will be O of 1, right? This is the solution. Hope you like it. Thank you. Bye bye.